How to use Dapper in C Sharp. In the most simplest terms, Dapper is a wrapper around ADO.NET. Of course, it's a lot more than that and acts as a micro ORM. It automates a lot of the code you would have written using just ADO.NET. It's small, fast, and safe against SQL injection attacks. Some of the more common functions of Dapper we'll be looking at is query to return multiple records from a database, query first or default to return a single record, and execute to perform non-query transactions like insert, update, and delete. Finally, we'll look at transactions and how to execute multiple commands in Dapper and then commit the changes or roll back all changes if an error occurred. We'll start by adding a configuration file to our console app where we can specify the connection string. We'll name the connection sample and set the data source to sample.db. Install two Nuget packages. For simplicity, we'll be using a SQLite database, so we need the Microsoft.data.sqlite package. And of course, we need the Dapper Nuget package. Next, we add a class to represent a model or entity in the database. The person class will have an ID, first name, and last name property. Add a services class to handle all the data access functionalities of the person model. We create a class-level variable to hold the connection string. In the constructor method, we retrieve the connection string from the configuration file based on the name of the connection string. You may have to do a control period on Configuration Manager and install the latest version. Our first method is simply to test the connection. In the try-catch block, we create a new SQLite connection using the connection string. Then we open and close the connection. In the case of SQLite, this will create the database if it doesn't already exist. Then we display a confirmation or the exception message if an error occurred. In the main method, we instantiate a person service object with the name of the database connection and call its test connection method. The connection is OK, and the database was created in our output folder. Our first database action is to create a table to store our person data. The SQL command creates a people table, if it doesn't already exist, with an auto-incremented ID value, first name and last name column. We use a using statement to create a SQLite connection object. This object will be disposed of when it leaves this block of code. Then our first Dapper method is execute. This is similar to the execute non-query method in ADO.NET. Dapper will open the connection if it's not already open, run the SQL command, and close the connection for us. Back in the main method, we call the person services create table method. The table was created or already exists. Let's start with the CRUD functions. In our person service class, we create an insert person method that takes a person object as argument. The SQL command inserts a record into the people table with the given first name and last name. Note we don't specify the ID value since this is automatically generated by the database. After creating a connection object, we call the Dapper execute command again, but this time we not only pass it the SQL command, but also a list of values for its parameters. In our main method, we create two person objects and add them to the database with our new insert method. The result shows two person records were created. Next, we'll add a getAllPeople method to retrieve a list of person objects from the database. We create a variable to hold the list of person objects to return, and a SQL command to do a simple select all from the people table. After creating the connection object, we use the Dapper query method and specify that it must return person objects as a list. In our main method, we call the getAllPeople method, then loop through the list of people and display each person's data. We'll do another get method, but this time to retrieve a single person record based on its ID number. We create a nullable person object and set it as null. This means if a person record with that ID doesn't exist, the method will return a null value. The SQL command selects the person based on its ID. The next Dapper method we use is the query first or default. This will return the first person it finds with the specified ID or a default value. The default value in this case will be null. Again, we specify it must return a person object and give a value to the ID parameter. In our main method, we call the getPersonById method with an ID value. If the returned person object is not null, the person was found in the database and the record is displayed. Next on the CRUD functions is the update method. Our update method will accept a person object that contains the ID of the person to be updated and the changed values. The SQL command updates all the columns for the person with the specified ID. Then we call the Dapper execute method and give a list of the values for the parameters in the SQL command. In our main method, we create the person object we wish to update with its ID and changed values and call the person services update person method. To check if the update worked, we read the person record back from the database and check that its values have changed. The last CRUD method is the delete person method, which takes the ID of the person to delete. The SQL command simply deletes the person with the specified ID. We call Dapper's execute method and set the value of the ID parameter. In our main method, we call the delete person method with an ID value, then try to read the person record back from the database. If the result is null, the record was deleted. A Dapper transaction allows you to perform multiple operations on a database, then roll back all operation if an error occurs in one of the operations. For example, if you need to update more than one table that pertains to the same data, but you don't want residue data remaining when the operation fails halfway through. In this demonstration, we'll create a SQL statement to insert a person record into the people table. First, we create a connection object and open the connection. For a transaction to work, the connection must already be open. Then, we created a transaction with the begin transaction method. Everything within the block that follows is part of the transaction. Here we can perform our multiple operations and commit the changes to the database. If an error occurs in one of the database operations, an exception will be thrown, and the commit statement will never be executed. There is no need to do a manual rollback. In our main method, we call the transaction method, then read all the person records back from the database and display the result. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.